All right, let's look at the six trig functions. The six trig functions are related to a right triangle. So we're going to consider this triangle in which one acute angle is labeled theta. Relative to the angle theta, the three sides are the hypotenuse, the opposite side, and the adjacent side. Now, you need to keep those in mind because we're going to be using them extensively here as we work with the definitions of the trig functions relative to a right triangle. Right, so what are those definitions? The six ratios were defined for circular functions can now be defined in terms of a right triangle and the angle theta. In the definitions, 0 is less than theta is less than 90, i.e. theta will lie in the first quadrant. So the value of each function is positive. What if there is an angle greater than 90? We'll discuss that later. So notice here our right triangle definitions. That theta be an acute angle, the six trigonometric functions of theta are defined on the next frame. Notice that the functions in the second row are the reciprocals of the corresponding functions. So we have the secant of theta now equal to the opposite over the hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and notice in the second row we have the reciprocals. The abbreviations OPP, ADJ, and HYP represent the lengths of the three sides of the right triangle. And so OPP is opposite, ADJ is adjacent, HYP is the length. These have to be memorized, just like the circular functions were memorized. All right, let's next do examples. There are several ways to evaluate trig functions. Given two sides of the triangle, use the Pythagorean theorem to find the third side. Then you will know the opposite, the adjacent, and the hypotenuse and be able to do the functions. All right, so suppose the opposite is 3, adjacent is 2. All right, theta, opposite is 3, adjacent is 2. Then the hypotenuse is 9 plus 4, the square root of 13. So the sine of theta, 3 over square root of 13, cosine, 2 over the square root of 13, and then and tangent, then remember the others are reciprocals. So we just easy to write them down. All right, let's try another one. Suppose the opposite is 4 and the hypotenuse is 6. All right, 4, 6. So now we have to find the adjacent, and it will be 36 minus 16, or the square root of 20. No need to simplify the square root of 20 unless you want to. So here we go. Sine of theta, 4 over 6. Cosine, 2 square root of 5 over 6. Simplify them algebraically if you want to, or 2 over the square root of 5 for tangent. The other three are reciprocals. Stop the video if you need to and review this because you're going to have to be able to do it without thinking too hard. All right, so there are several ways we said. We've done the first one. Now, let's say that one of the acute angles is given one of the acute angles of the triangle is easy when the angle is 45, 30, or 60. 45, we've got an isosceles. So opposite is 1, adjacent is 1, hypotenuse is the square root of 2. Let's check out an example of this. Suppose theta is 45. So let the adjacent be 1, the opposite be 1, and the hypotenuse will be the square root of 2. Easy, easy. So now we draw our little triangle here so that we can visualize this. So the sine of theta will be 1 over the square root of 2. Cosine, notice here the sine and cosine are the same and the tangent is 1. The other three are easy. They're just reciprocals. All right, good, good. You got that down pat. Try a few if you need to. Sine and cosine are less than 1. Recall the domain. Right, now again, we've looked at the first one. We've looked at the first piece of the second one, and that is, what if we have an isosceles right triangle? Now, for a 30, 60, or 60, use your relationship from geometry. or 1/2 of an equilateral triangle. For example, for 30, the opposite's 1. The adjacent is square root of 3. Hypotenuse is 2. For 30, remember the opposite side is half of the hypotenuse. So got to get that in mind because these are some that you're going to be expected to know without computing them every time. Okay? Expect to know them without computing them. All right, so here we go. Let's do an example. Suppose we've got a 30. Let's keep it easy. The hypotenuse is twice the side opposite the 30. So the cosine of 30 is the square root of 2 over 2, and the sine is 1/2. Notice you don't have to do these in any order. Here I reversed the sine and cosine. Not sure why. I don't know. I was just writing and did it. For 60, similarly, except that notice where I put the 60, and so the 30 then, I was messing up. So we've got 2 on opposite, 4 on hypotenuse, 16 minus 4, or 2 square root of 3. All right, you're getting the hang of it. You've got those definitions memorized, I hope. And so we're right with it here. Moving right along, you get the 3. It's real easy to do the others. Notice the relationship between the cosine of 30 and the sine of 60. Similarly, very important. All right, we've looked at all of number 1 and number 2. Okay? If you need to do a few more problems, stop the video and try a few more on paper and pencil. Now we come to the third option. This one's always nice, and that's use a calculator. So let's check out both calculators that you might be using. All right, we've got it on. We're adding a calculator here. What do we need to do? We need to put it in degrees. So we go up here and we're going to put it in degrees. Okay, so we hit the trig button. We want the sine. And so let's do the sine of 50. Now, notice that relationship. I pointed it out to you about the relationship between the sine and cosine. They are complementary angles. Cosine, complementary. All right, let's do a tangent. So the tangent of 70, put a decimal, we get that nice number right there, and life is very nice. Let's do this secant while we're here. Okay, let's do the secant of 42. Ah, there we go. Notice the secant's greater than 1. All right, now let's check out the TI-89. Those are the numbers that we'd been working with before. So we need to go to mode, come down here to radian, change it to degree. Now we're in degrees. So look for the key that says sine, hit sine, and then let's see, let's do the sine of 41. Notice we put a decimal point in. Let's do a cosine here, just to get used to it. Cosine of 75. Whoops, I forgot my decimal point, so look at that interesting number. That's not a very meaningful number, so I hit diamond enter, and I get good old 0.258819. Nicer number to try to work with, as we can see. All right, let's try a secant. Now, we might have a problem with the secant. Let's see what happens here. Ooh, that means my calculator does not have a secant. So how can I get a secant? 1 divided by the cosine. The relationship's very important. So you need to learn these following relationships. You need to know what the sine of 30, sine of 45, sine of 60, cosine of each, and tangent. In addition to the above, remember to learn the functions of 0 and 90 degrees, which correspond to 0 and pi over 2 radians. You must know these. You don't have time to look them up.